In July 2025, a telescope in Chile caught something flying through our solar system that has no business being here. It's not from our sun, it's not from any planet we know. It came from another star system entirely, and it's only the third object like this we've ever found. Scientists just got their first real look at what it's made of, and the chemistry doesn't match anything that's ever formed around our sun. Here's what they found, and why it's changing what we thought we knew about how solar systems are built. We've only ever confirmed two interstellar objects passing through our solar system before this one. The first was Oumuamua back in 2017, a strange cigar-shaped rock that tumbled through and gave off zero gas. We never even got the chance to study its chemistry. It was gone before we could really look. The second was Comet 2I/Borisov in 2019, an actual comet, finally, with a tail we could analyze. Then in July 2025, the Atlas Survey telescope in Chile spotted a new one. They named it 3I/Atlas, the third confirmed visitor from outside our solar system, ever. And here's why that number 3 actually matters. These things aren't rare because they don't exist out there. They're rare because we've barely had the technology to catch them in time. Every interstellar object we do catch is basically a free sample of another star system, delivered to our doorstep, and we only get to study it for a few months before it's gone forever. So when one shows up, astronomers move fast. Here's the thing about comets in our own solar system. They all formed out of the same disk of gas and dust that built the sun and the planets. So when scientists study one of our local comets, they're basically studying a leftover ingredient from our own creation. Same recipe, same kitchen. 3I/Atlas is different. It formed around a completely different star, under conditions we've never been able to sample directly, which means its ice, its dust, its gas, all of it, is a chemical record of a star system we will probably never visit in any other way. So the real question becomes, what's actually inside this thing? That's where it starts getting weird. As 3I/Atlas got close to the sun, astronomers pointed the James Webb Space Telescope at it and measured the gas boiling off its surface. The first surprise, it was releasing far more carbon dioxide relative to water than any comet we know from our own solar system. We're not talking about a small difference. The ratio was so far outside the normal range, multiple standard deviations beyond the trend we see in both long-period comets and the shorter-period ones near Jupiter, that it told scientists almost immediately this thing did not form anywhere close to our sun. That was clue number one. Then came something stranger. Earlier analysis of 3I/Atlas found it putting off an unusually large amount of methanol. Basically, this comet had alcohol baked right into its ice. Now, that's not totally unheard of. Some comets in our own solar system have methanol too, but the amount compared to everything else in the comet's chemistry was unusual enough to make astronomers pay close attention. Two strange chemical signatures in, and a pattern was starting to form. This object kept breaking the normal comet rulebook. But the biggest discovery was still coming. In December 2025, as 3I/Atlas was heading back out of our solar system after swinging around the sun, Webb's MIRI instrument caught something that had never been directly detected on any interstellar object before: methane gas. Here's why that's such a big deal. Methane is extremely volatile. It boils off easily, way before water does. Normally, you'd expect a comet to lose its methane early, long before it ever gets close to the sun. But 3I/Atlas held on to its methane the entire time. The explanation scientists landed on: the methane had been buried deep below the surface, insulated from heat, until the comet's close pass to the sun finally drove warmth deep enough to release it. And the amount of methane compared to water was way higher than anything we see in solar system comets. Put that together with the carbon dioxide excess and the methanol from earlier, and the picture becomes pretty clear. This thing formed somewhere colder and farther from its home star than anything that built our own solar system's outer edge. 3 independent clues, same conclusion. This is not solar system chemistry. Now, anytime an interstellar object shows up, one name almost always enters the conversation: Harvard astronomer Avi Loeb, known for floating the idea that Oumuamua might have been artificial, he's raised similar questions about objects like this one too. That idea gets enough public attention that it's worth actually addressing and then explaining why most of the scientific community isn't convinced. Here's the reason. Every single thing Webb measured, the gas ratios, the way production dropped off as the comet cooled, the timing of the methane release, matches known physics for how ice behaves under solar heating. None of it requires anything beyond natural cometary behavior. Unusual chemistry isn't the same thing as impossible chemistry. It just means this comet formed somewhere we've never been able to sample directly before. And honestly, that's the more interesting answer anyway. We don't need aliens to make this object remarkable. The truth is wild enough on its own. Put all of it together, and 3I/Atlas gives astronomers their first detailed chemical fingerprint of material that formed around a completely different star. That's a massive deal for a field that spent decades only able to study planet and comet formation, using our own solar system as the one example we've got. Every gas ratio, every chemical signature, every clue from this comet becomes a new data point for understanding how other solar systems form, what's common, what's different, and what that means for how common solar systems like ours actually are across the galaxy. This is one comet. Imagine what the next one tells us. 3I/Atlas isn't sticking around. Like every interstellar object before it, it's already on its way out of our solar system for good, never to return. Every observation taken over these past months is the only data we will ever have from this specific object. That's part of what makes catching these things so valuable. And it's part of why the next one, whenever it shows up, is going to matter just as much. If a story like this is the kind of thing you want more of, real space science, told like it actually deserves to be told, subscribe. Because the next interstellar visitor is a matter of when, not if, and I'll be covering it the moment it happens.